Welcome to Make Made Simple. Today we'll be studying moment of a force about a given axis and its physical meaning. So I have a plane here on which a point A is there and OA is a vector. Then a force F is applied to point A and we have a axis here OL on which the position vector R vector R1 vector we have resolved R vector into R1 vector and R2 vector, and we have resolved F vector into F perpendicular and F parallel. F perpendicular is perpendicular to this line to this line, and F parallel is parallel to this line. So moment about OL equals lambda vector dot m moment about O vector. MOL is equals to lambda vector cross dot R vector cross F vector that we had done in the previous lecture. Then MOL is equals to lambda vector dot R1 vector plus R2 vector cross into F parallel vector into F perpendicular vector, and we have lambda vector is equals to R1 vector cross F parallel vector plus lambda vector dot R1 vector cross F perpendicular vector lambda plus lambda vector R2 vector cross F11 vector F parallel vector plus lambda vector into R2 vector cross F perpendicular vector. Now all these terms will become 0. This will become 0 if you look closely at this and multiply R vector cross F vector, R vector, R1 vector cross F vector dot lambda vector. If you do, it will be 0. Similarly, this will also be 0. This will also be 0. We are only left with this lambda vector into R vector 2 vector cross F perpendicular vector. So MOL is equals to R2 vector dot F1 vector magnitudes of R2 vector and F1 vector. Now, what is the conclusion of this derivation is that the moment MOL of F force about OL measures the tendency of the force F to impart to the rigid body a rotation about the fixed axis OL. So that was the conclusion for today. If you have liked the video, please do like the video, subscribe to my channel and share it among your friends. Thank you.